In this video, we're going to have a look at what is Pixie Enhanced Authorization Code Flow grant type and how to implement it. In part 1 of this tutorial, we covered the basics of Oauth2 and understood what is Authorization Code Flow grant type and how to implement it using Spring MVC application. So if you're watching this video for the first time, have a look at part 1 so that you will get complete information and context about this tutorial. Now without any further delay, let's start the video. PKCE Authorized Code Flow, spelled as Pixie Authorization Code Flow, stands for Proof of Key Code Exchange Authorization. This grant type was created to be used for public-facing clients, for example, web applications which are developed using JavaScript frameworks like Angular, React, or Vue, and also mobile applications. The Pixie Authorization Code Flow is mainly considered as a best practice to follow when we are using public clients. The main reason for using these kinds of different authorization code flow is because if you remember, as part of the authorization code flow, we saw previously that to get the access token and ID token pair from the authorization server, the client needs to make a post request with the client ID, client secret, and the authorization code. So that means we have to store the client secret somewhere in the client to be able to make a post call for the token endpoint. This is very risky because any web developer can view the source code of the JavaScript applications and find the client secret if we store it in the client. So the same also applies for the mobile application. So if you have the APK file and you can decompile or decompile that APK file to view the source code. So it's not safe at all to store the client secret inside the client source code. So for this reason, a new type of authorization code flow was designed, which is the Pixie Enhanced Authorization Code Flow. This flow is very similar to the authorization code flow, but with a couple of additional steps. And also, there is also no need to maintain the client secret anymore in the client by using this approach, as I said before. So let's go ahead and see how it looks like. In the Pixie authorization code flow, similar to authorization code flow, we will make an initial request to the authorized endpoint of the Keycloak server with some query parameters. Parameters we are sending are almost similar to what we sent as part of the authorization code flow. So if you need to understand why we need these parameters, have a look at part 1 of this video. I am not going to repeat this information again. So as part of the Pixie authorization code flow, we are going to send 2 additional URL parameters. The first one is called as code challenge, which is a base64 encoded random string, which is generated by hashing and encoding another value generated by the client called as code verifier. The next parameter is called as code challenge method, which should be configured inside our authorization server when we are first configuring the client. The recommended value for this code challenge method parameter is S256, which is a cryptographic hashing function. Once the clients make this request to the authorization server, the server responds with a login page asking for the user to authenticate. Once the user logs in, the authorization server returns an authorization code similar to the authorization code flow we saw in part 1 of the series. But now to request an access token, the client should send the code verifier value along with the authorization code as part of the post request to the token endpoint. When the authorization server receives this post request, it validates the authorization code and the code verifier values and then responds with an access token and ID token pair. Once the client gets this token, it can now make the request to access the resource to the resource server, and the resource server will first validate whether the token is valid or not. So this is how the Pixie authorization code flow works. Hope you have understood this theory. Now let's see this grant flow in practice and then implement it using Spring Boot and an Angular application. Okay, so now let's see the Pixie authorization code flow grant type in practice. For this, I already started the front-end and back-end applications, and in the browser, I have the network tab open, and I'm going to hit the endpoint localhost 4200, and in here, you can see the link login. If I click on it, you can see similar to the authorization code grant type, we have the initial authorization request to the Keycloak server, which returns a login page. If you check the parameters, which are part of the authorization request, you can see the response type as code, the client ID, and a state parameter. The additional parameter added to this request URL is the code challenge and code challenge method. These values are generated by our Angular application, and the Keycloak server responded with a login page for this request. Now let's go ahead and log in. I'm going to type in my credentials and click on login button. Now you can see the request which is made to the redirect URI. If you check the query string parameters again, we see the same query parameters as the previous authorization code flow. We have the state parameter, the state session, and code. Our Angular application will use this code to make a post request to the token endpoint, as this is a public Angular application. So if we have a look at this request, it goes by the name token. So it's easy to identify, and as I mentioned before, this will be a post request with request body as the authorization grant type, the authorization code, the redirect URI, and client ID. Lastly, we have a new parameter called code verifier. This value is used to verify the code challenge method, the value code challenge, just as explained in the previous section. Now if you check the response of this call, you can see the value for the access token, the expiry time of this token, followed by the refresh token and its expiry time. So if our client needs to make any calls to a resource server, it can make use of this access token, and if the access token is expired, it can use the refresh token to request a new access token. Now this is how the Pixie authorized code flow works. So let's go ahead and see how to implement this grant type. Okay, so first of all, we are going to start by creating a client inside Keycloak. For that, make sure you have the Keycloak server up and running and open the address localhost 8180 and log in with your admin credentials. Now if you click on the Clients tab and click on Create button, we are going to provide the client ID as Oauth2 demo Pixie client and click on Save. And now here we have to make some changes. First of all, we have to select the access type as public, as we are using a Pixie enhanced authorization code flow for the JavaScript client applications. So we will leave the standard flow enabled as on, as it's also called as authorization code flow. We will leave also the following options as defaults, and we have to provide the value for valid redirect URI. So this is the URI where the authorization server will send the authorization code and the client reads the code. So I'm going to provide here the value localhost 4200, which is the address of the Angular application. The next value we have to provide is for the web origins. So this would be the allowed CORS origins which can access the authorization server. So we are going to provide a star here, as we are going to permit all origins. So when you are using this for production applications, please don't provide a star value here and only provide the valid origin of the redirect URI you are going to use. So that means if your front-end application is running on a server, provide the host details of the server instead of allowing all origins. Alright, so the next value we are going to configure is the Pixie enhanced code challenge method. You can find this value under the advanced settings, and I am going to select the value as S256, which is a cryptographic hashing function, which will be applied on the code verifier value. So if you select plain, there won't be any hashing performed on the code verifier, and this is not a secured option and this is highly discouraged. So that's it for the client configuration. I'm going to click on save. So now let's go ahead and dive into the code. So similar to part 1 of this video, you can download the starter code from the GitHub repo. You can find the repository in the description section of this video. So the main branch contains the completed code, and the starter code is provided in the initial branch. So if you are stuck for any reason, you can refer to the completed code in the main branch. So in this video, we are mainly interested in the Pixie authorization code flow. So once you open the Oauth2 Pixie demo project, under the source main resources folder, you will see a folder called frontend, which contains the code for the Angular application. So the first thing we are going to do is to install a package called Angular Oauth2 OIDC inside our Angular application. This package will provide Oauth2 capabilities for our Angular application by just writing some minimal code. So this package supports both authorization code flow and Pixie enhanced authorization code flow. So let's go ahead and add these details inside the package.json file. So at the time of creating this video, the Angular Oauth2 OIDC package is on version 10.0.3. So once you have added this dependency, run npm install to download and install the package to your machine. Okay, now we have to configure the client details inside the application. For that, I'm going to create a new file called auth.config.ts inside the app folder. And inside this file, I'm going to define an object called authconfig, which is of type authconfig coming from the Angular Oauth2 OIDC library. So I'm going to type export const authconfig and declare the return type of the object. And inside the object, I'm going to define 6 fields. The first one is going to be the issuer URI. So if you have watched the part 1, I already discussed what is issuer URI in detail. So please have a look at this video if you didn't watch it yet. So this issuer URI contains all the list of configuration endpoints which is exposed by the authorization server. So you saw in the theory part that our client is going to make multiple calls to the authorization server. The first one is the initial authorized request and followed by the token endpoint request. And subsequently, it will also make a request to refresh the token if needed. So instead of hard coding all the endpoints in the application, you can just provide the issuer URI, which will expose the list of endpoints, and then the client can use this list of endpoints and call whatever endpoint is required. Okay, the next value is going to be redirect URI. This is the same value we provided when configuring the client in the previous section. So instead of hard coding this value inside our code, you can provide the JavaScript window object like window.location.origin, which will return the address of the web application. The next value is going to be the client ID, which is Oauth2 demo Pixie client. Again, we have to provide the same value as we provided inside the client. So it's better to copy this value from the client information in Keycloak and paste it here. The next value is going to be response type. This is going to be code as we are following authorization code flow mechanism. Even if it's Pixie enhanced, we provide the value as code itself. So the next value is going to be strict discovery document validation. So this is something which is relevant to this Angular Oauth2 OIDC library. So we are going to provide it as true. So this is used when the list of endpoints exposed by the issuer URI endpoint does not contain the same base URI as the issuer endpoint. So what do I mean by that? So if I open the OpenID configuration of a realm, you can see that by visiting the realm page inside our Keycloak server and click on OpenID configuration link, you can see that the base URL of all the URLs are same. Because we are using Keycloak as the authorization server, it is going to be consistent. So if for any reason we anticipate the base URL is not going to be consistent across all these URLs, then we'll provide the value as false. So in those cases, our application will not validate the discovery document, that is the JSON we are seeing here for the base URLs. Alright, moving ahead, we have the last parameter called scope. Here I am going to provide some default scopes like OpenID, profile, email, and offline access. After configuring these values, now let's implement the flow. It's very easy. I'm going to open the app component HTML page and remove all the default HTML which exists inside the file. And I'm going to replace it with just some bare bone HTML code. So I'm going to add an anchor tag with text called login and another anchor tag with text logout. So if I click on this link in the browser, it should make the authorized call to the authorization server as seen in the theory, which is step 1. So to do that, I'm going to make use of the out-of-the-box functionality provided by the Angular Oauth2 OIDC package. So I'm going to first inject the Oauth service class into the component which is coming in from the library. Make sure to import the class into the component. And after injecting the service, we should provide the auth config details to the service. We can do that by first creating a method called as configure. So let's define and create this method. And inside the method, I'm going to type this .oauthservice.configure and pass in the Oauth config object as the argument. Also, make sure to import this object into the component. Now I'm going to type this .oauthservice.loadDiscoveryDocument and try login. So what this method call will do is to make a call to the issuer URI and get all the necessary endpoint required to trigger the login flow. Okay, now we are ready to trigger the login flow. For that, we can make use of the convenience methods provided by the Angular Oauth2 OIDC package. For that, I'm going to create two methods, login and logout. So first, inside the login method, I'm going to type this .oauthservice.initCodeFlow, which will kick off the authorization code flow. And inside the logout method, I'm going to type this .oauthservice.logout, which will take care of logging out of the application automatically. So you see how easy it is to implement authentication and authorization using this library. So it makes our life easier as the developers. And if you want to implement it manually, so it's going to take lots of time and effort to do it. So due to this flexibility provided by the libraries, it's important for us developers to do due diligence and understand how it's working under the hood. So that's where the videos like this are going to help you. So if you like it so far, don't forget to like the video and subscribe to our channel to check out more interesting tutorials like this. Alright, now let's come back to our tutorial. So we configured the required methods inside the app component TypeScript file, but we are not yet calling these methods from our HTML file. So let's open the app component HTML and call the login and logout methods when clicking on this link. So I'm going to use the click directive and pass in the login and logout method definitions there. So now if I click on the login link from the browser, it should kick off the Pixie Authorization Code Flow mechanism. Alright, now let's start up our Angular application. For that, I'm going to type npm start in the terminal and make sure you are in the front-end directory. And once the application is started up, open localhost 4200. So now you can see that we don't see any links here, any hyperlinks with login or logout, because we have an error because the Oauth service is not understandable by the Angular modules for our Angular application. This is because we have to define the Oauth module inside the appmodules.ts file. So I'm going to open the appmodule.ts file, and in there I'm going to, under the import section, I'm going to type Oauth module.forRoot, and inside the configuration section, I'm going to provide the object for resource server, and inside there I'm going to provide what are the allowed URLs for the resources server. So this is going to be http localhost 8080/API. We did not yet create the resource server, but we will do it shortly. You will have a look at it shortly. And the second variable is going to be send access token true. So we are also going to see in detail like what does actually this particular variable and declaration means. So now as we've done that, we will also define the HTTP client module, because we will make a call to the resource server and we need access for the HTTP client to make a GET request. So in this way we are covered also for the HTTP client module to be accessed from our Angular application. So once you've done that, you can restart the Angular application and open the browser again, the localhost 4200, and refresh the page. And now you can see two text values, login and logout. And I'm going to first open the DevTools and network tab. So you can see the network calls while logging into the application. Click on the link login, it will open the login page. And as part of the first request, you can see the value code challenge, which is generated by the Angular Oauth2 OIDC package. And we are also sending the code challenge method as S256, which is the same value as we configured inside the Keycloak client. So the rest of the query parameters are similar to the authorization code flow. And coming back to the browser window, I'm going to type in my credentials, which I created in part 1 of this series. And once I click on login, and if we check the network tab inside the DevTools again, you can see that it made the call to authenticate followed by the OpenID configuration call. So this is the discovery document which is returned by the authorization server. So if you see the response, you can see all the information we saw before here, and the client will make use of this data to make a token endpoint post call to the authorization server. So you can see that also see that it sent the grant type as code, the authorization code it received from the Keycloak, the redirect URI, the code verifier which is generated by the Angular Oauth2 OIDC package, and the client ID. So once the Keycloak server receives this request, it will decode the code challenge value provided as part of the initial request. So you can see here in the diagram in step 1, using the S256 cryptographic hashing function, and verifies whether it's same as the code verifier or not. If yes, then it will respond with access token and ID token, and the token value is stored inside the session storage by default, as I'm using an incognito window. So you can use this access token to request the resource server and access the protected resource. So this is how we implement Pixie authorization code flow on the client side. Now let's implement the resource server part. So if you go back to the source code, we have our Spring Boot application which just contains a main class as of now. So to configure the resource server, we have to first add some dependencies to enable Oauth2 resource server capabilities. For that, I'm going to open the pom.xml and add in 3 dependencies. The first one is going to be Spring Boot Starter Oauth2 Resource Server, which will enable the resource server capabilities inside our Spring Boot application, followed by Spring Security Oauth2 Jose dependency, which will also enable the JavaScript object signing and encryption framework, shortly called as Jose framework, which is used to securely transfer claims between two parties. This means transferring the JSON web tokens, the JSON web signatures, JSON web encryption, and JSON web keys. So I'm not going to go over this in details, but in a nutshell, it makes sure that the keys and tokens are transferred securely between two parties. Lastly, I'm also going to enable Spring Security in this project using the Spring Boot Starter Security dependency. After adding all these dependencies, if you are using IntelliJ as your IDE, make sure to click on the Maven icon on the top right corner to force IntelliJ to download the dependencies. Now it's time to configure the resource server properties. For that, I'm going to open the application.properties file and define a property spring.security.oauth2.resource-server.jwt.jwt-set-URI. So this is the property which will point to the key set URI of Keycloak, which is used to verify the access token and ID token we receive from the client. Here you can see this in the diagram in step 7 and 8. For this, I'm going to open the OpenID configuration of the Keycloak server by opening the realm and clicking on the OpenID configuration link. And I'm going to copy the value for JWKS URI and paste it inside the file. Okay, we have configured the resource server. Now let's create an endpoint to act as a resource. For that, I'm going to create a package called as controller, and inside the package, I'm going to create a class called as home REST controller. As this is going to be a REST controller, I'm going to add the REST controller annotation from Spring MVC followed by the request mapping. I'm going to expose the endpoint at /API/home, and I'm going to also configure the cross-variance annotation with value as star. So inside the class, I'm going to create a method called as home, which returns a string. And inside this method, I'm going to return a string called hello. As this is going to handle a GET request, I'm going to add the GET mapping annotation followed by the response status annotation with value as OK. Alright, we configured also the endpoint, and the last thing which is remaining is to configure also the Spring Security. For that, I'm going to create another package called config, and inside this package, I'm going to create a class called as security config. This class should extend the web security configurer adapter. So in this way, it will override the default Spring Security configurations which are defined by the framework, and I'm going to add the configuration annotation on top of the class. I'm going to override the configuration method here, and inside the method, we can customize how Spring Security should behave. So first of all, I'm going to make sure that all requests to our resource server should be authorized first. So I can do that by chaining the authorized request.andRequest.authenticated method followed by the session management and session creation policy. As this is going to be a REST backend, it should be stateless. And finally, we are going to add the CORS annotation to inform Spring Security that it will be taken care by the cross-origin annotation we added a moment ago. And lastly, I'm going to disable CSRF and configure the resource server and JOT token capabilities inside our Spring Security framework. So we are chaining so many calls here, but that's how Spring Security configuration works. And so we are done with the backend configuration. We enabled resource server capabilities and created an endpoint. Now let's go back to the Angular application and make a request to the resource server after successful login. Alright, so now I'm inside the Angular application, inside the terminal. I am going to first create a service class which contains logic to make calls to our resource server. For that, I'm going to type ng-gs app, which is going to create a class called as appservice.ts and appservice.spec.ts files. We are only interested in the appservice.ts file right now, so I'm going to open this file, and in here we have to make a HTTP GET request to our resource server. For that, I'm going to first inject the HTTP client into the service, and after that I'm going to create a method called as hello, which will return an observable of string, as we are returning a string as a response from our backend. Inside the method, I'm going to first define HTTP headers, by setting the content type as text or plain. The reason being, as I mentioned, we are returning a string as a response. Now I'm going to make the GET call using the HTTP client to the URL localhost 8080/API/home, and now we are going to pass in the headers as the next argument for the GET method. So when the HTTP client makes a GET call to this URL, it will include these headers and also make sure to add the return statement so that it will return the observable. So we implemented the service call. So what is remaining now is to call the service from our component. So for that, I'm going to open the app component TypeScript file. And in here, the first thing I'm going to do is to inject the app service class. And inside the constructor, I'm going to call the hello method from the app service and subscribe to the observable returned by the method. Inside the subscribe method, I'm going to read the response and assign it to a variable called text. Let's store this subscription inside a variable called hello subscription, which is of type subscription, and we have to unsubscribe from the subscription when the component is destroyed. So for that, I'm going to implement onDestroy interface for this component, and inside the ngOnDestroy method, I'm going to type this hello subscription.unsubscribe. This will make sure that there are no active subscriptions lying around, which can cause memory leaks in the application if not given sufficient attention. Alright, the last and final thing we are going to do is to bind this variable to our HTML page. So for that, I'm going to add in a h1 tag and bind the text variable, as I don't want to write much code and keep this video relevant to Oauth2 and Keycloak. To display the response from server, we have to refresh the browser after the login. So I'm going to add in the message also here. Okay, so we completed the implementation part on the front end as well as the back end. Now let's start our front-end application by typing npm start and make sure that the backend Spring Boot app is also up and running. Alright, now let's open an incognito window and open the address localhost 4200 and click on login. Now I'm going to type in my credentials, and after clicking on login, you can see the home page. So let's refresh the page and you can see the response from the backend as hello. Now you may ask, how did our Angular application recognize the token and send it part of the request to the resource server automatically? So this is done by the Angular Oauth2 OIDC library automatically. So that is one less thing for us to care as the developers. So that's it for this video. I hope you learned something new from this, and if you like this kinds of video, please like the video and subscribe to my channel for more interesting tutorials like this. I will see you in the next video with part 3 of this series, where we are going to see how the refresh token grant type and the client credentials grant type works. And we are going to see how to implement social login using GitHub through Keycloak. So until then, happy coding techies and goodbye.